Hello, Hannah. Greetings from snow-covered Michigan, where it is currently 18 degrees out. I'm sure you're going to have quite a different climate down in Florida. And again, wish you just the best time while you're down there. Enjoy it. But school still continues. So here is the teaching that I promised you for math today. We did a new lesson in class. And today this is lesson 5-7. I did skip ahead a little bit to break the chapter down into parts that relate to each other better. So as a heads up, this is again, what we talked about. This is the last lesson in the unit before your next test. So on Wednesday, I will give the class their practice test. Which is something that I can pass on to you. But that's something that then we can go over with once you get back before you have to take the test. We can give yourself a few days. So for today, let's move on to Chapter 5, Lesson 7. It is on least common multiple, or abbreviated because it's a lot of words to write, LCM. So LCM stands for least common multiple, and you'll be doing two concepts today. Both of which I think are fairly simple and could be fun because we'll be making factor trees again for the second concept. But just to get you familiar with the idea of a multiple, I've given you several examples here. 12 is a multiple of 2 because 2 times 6 equals 12. In other words, a bigger number is a multiple of a smaller number if you can think of any whole number that would multiply by it to get the bigger number. So smaller number times any other whole number, if it can equal the bigger number, it is a multiple. So in other words, you can multiply 2 times something to get 12. So 12 is a multiple of 2. And the advantage you have with a video like this is that if you're not following something, you can rewind, go back to the start and listen through again, a second time or multiple times. But a few more examples of multiples. 12 is also a multiple of 3 because you can multiply that 3 by 4 to get 12. So in other words, the smaller number multiplied by another whole number makes the bigger number. So since you can do 3 times 4 equals 12, 12 is a multiple of 3. And then a negative example, 25 is not. 25 is not a multiple of 4 because 4 times nothing equals 25. You cannot think of a whole number to multiply 4 by to get the bigger number. The smaller number times nothing that you can think of makes the bigger number, so 25 is not a multiple of 4. So some of your homework today, about half the problems will be asking you, is a bigger number a multiple of a smaller number? And that's the way that you would handle those problems. On my end, the advantage of teaching you, let's do it this way. I'm gonna pause my video, but for you, there won't be a pause. I'm gonna write down a few examples for you to try, and then we'll go over those answers to see how well you are grasping the concept. So I'm gonna pause, but I'll be right back, and for you, it'll seem like the blink of an eye. There, I am back. I think we had a pretty big glitch in the camera not working, so I was only gone a few minutes, but there might be a few back and forth here. But here are the example problems from the first concept. So the first question for you to answer is 50, a multiple of 10. So I'm going to give you a second to look at that and ponder it over and see what you think. Then we'll go over the answer. And then also we'll move on to the second one. If you are done with the first and move on to the second before I start going over the answer, you certainly can work ahead and do that. So I'll give you another few seconds here on the first one. Is 50 a multiple of 10? All right, so the question is on these, can you think of 10 multiplied by some number to equal the big number? And of course you can, because 50 ends in a 0, so 10 will multiply by 5 to get 50. So the smaller number multiplied by another whole number equals the bigger number. So 50 is a multiple of 10. Next example, is 36 a multiple of 8? So I will give you a few seconds here to look at that one and see what your answer is. But I'll formulate it. So this one's yes. 50 is a multiple of 10, but is 36 a multiple of 8? So as you've thought about it, the question really is, can you think of 8 times a number that will equal 36? And guess what? There is no number, so there's nothing you can multiply 8 by to get 36. So the answer to the question is no, because the smaller number times nothing we can think of can multiply to get the bigger number. So that's your first concept. I am going to hit the pause button again. Hopefully we won't have a glitch this time, so I can put some things up on the board for teaching you concept number 2. All right, no glitches here this time. Through the magic of technology, I now have the steps written down for our second concept. And what's nice about this as well is that you can pause this at any time to make sure that you have this all written down. So we are going to find the LCM, the least common multiple. Step 1 is we're going to make factor trees. So we've already learned how to do that in previous lessons. So that should be straightforward for you. And then step 2, here's where in English you might have a little struggle following along, but when we go through the examples, I'm sure that will all clear up. But for now, step 2 is to circle the largest number of each prime factor in either of the factor trees. And then step 3 is to use all of the numbers you circled and multiply them together, and that will get you the least common multiple. So again, probably a little unclear at the moment, but write these steps down. I'm going to pause again, and when we come back, I'll have a first example up on the board to work. And I am back. Voila! Here is your first example. Find the LCM, the least common multiple of 4 and 6. I've already done step 1 on the board. I did a factor tree for 4, and I did a factor tree for 6. Step 2 is now really the new part of what you're learning. And what we meant by circle the largest number of each prime factor in either of the factor trees is we look at each of the prime factors. There's a 2 here and another 2 here. So in other words, there are 2 2s as ends of the branches as prime factors of our factor tree for the number 4. So there are 2 2s here. There is 1 2 here. Which of these has more 2s? Yep, it's that one. So I circle the factor tree with the biggest number of 2s. If I look at this factor tree, there are no 3s, and there's 1 3 over here. So which of the factor trees has more 3s at the end of the branches? Yep, this one. So I circle the 1 3. That's the end of step 2. Then step 3 is to take those largest groups of each prime factor and multiply them together. So I've got my 2 2's that I've circled. I'm going to use both of those for multiplication. And I've circled my 1 3 here because there weren't any here. So I use that 1 3. And then when I multiply those numbers together, 2 times 2 is 4. 4 times 3 is 12. So 12 is the least common multiple for 4 and 6. Or in other words, 12 is the smallest number that I can think of that 4 times something makes 12, 4 times 3 makes 12, and 6 times something makes 12. 6 times 2 makes 12. So this is the smallest number that both of these can have a number to multiply by to get that. Okay, so that's example number 1. I'm going to pause again, and in the blink of an eye, you will have example number 2 before you. Ta-da! Here's our second example. Find the LCM of 30 and 80. And I've already made the factor trees for 30 and 80. And so let's walk through each of the prime factors. I usually like to start with the smallest one first and work up. So I'm going to start with this number 2 here. There's 1 2 in this factor tree. There are 1 2 3 4 2's in this factor tree. So which of the factor trees has the biggest number of 2's? Yep, it's this one. I'm going to use all of those 2's, 1 2 3 4 of them, to multiply for my answer. Then I'll look at the 3's. There's 1 3 here. There are no 3's here. So which of the factor trees has the biggest number of 3's? Yep, this one, because there's 1 compared to none. So that's the biggest number of 3's in either of the factor trees. Then you use that 1 3. And then here a question will come up oftentimes for students. When I look at the number 5, I have a 5 here. I have a 5 here. It's a tie. Both of them have 1 5. So the question is, though, what's the biggest number of 5's in any of the factor trees? And since it's a tie, 1 5 is what you use for your final solution. So if there ever is a tie for a number, you just use that many of the numbers. So what if, for example, I had 2 5's here and 2 5's here? Then they would tie with 2 5's, and I'd have 2 5's down here. Okay, my final answer then, if you'll trust me, when you multiply all these together, it equals 240. So what does that mean? 240 is the smallest number that you can multiply 30 by something to get, and 80 by something to get. So there's example number 2. We're going to go through one more example together, and then I'm going to have you try a couple. So here we go again. Amazing. Here's our next example. Find the least common multiple of 7 and 12. Well, notice there's no factor tree here. That's because 7 is already a prime number. So I've just got the 7. And then 12, I've made my factor tree 4. And so I'll go through the numbers. Again, I like to start with the smallest number first usually. So I'll look at the 2's. There are 2 2's here. There's no 2's here. The biggest number of 2's in either of the factor tree is 2 of them. So those 2 become a part of my answer to multiply together. There's a 3 here. There's no 3's here. So the biggest number of 3's in either factor tree is this 1 3. So I'll use that as part of my answer. And then there is a 7 here, and no 7's here. So this is the biggest number of 7's. So I'm going to use that as part of my answer. And 2 times 2 is 4. 4 times 3 is 12. 12 times 7 is 84. So in a split second, I'm going to write up a problem for you to try. All right, here is your problem to work out. Find the least common multiple of 12 and 20. So make your factor tree, circle the largest amount of numbers on either of the factor trees, write them down, multiply them out. So again, you can pause this video at any point. I'm going to pause it now so I can put the answer down. and click to resume this recording as soon as you've finished working on this problem. Okay, let's see how you did. Here's the factor tree for 12. And again, remember, there's different ways you can do a factor tree. I could have started out with 3 times 4 and then gone further down the tree, but you'll still end up with the same prime factors at the end of each branch. So here's the factor tree for 12. Here's the factor tree for 20. Let's start with the 2's. There are 2 2's here. There are 2 2's here. It's a tie. What's the biggest number of 2's in either tree? Well, they both have 2, so I'm going to use 2 2's as part of my answer. If I move on to the number 3, there's 1 3 here. There's 0 3's here. So the biggest number of 3's in either tree is one of them. So I'll use that one. And then I have a 5 here. No 5's here. So this is the biggest number of 5's in either of the tree, just 1 5. But I'll use that as part of my answer. And so my final least common multiple then is 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So 60 is your answer. I hope you did well. But whether you did or didn't, let's move on to one more for you to work on before I give you your assignment for today. All right, here is your next one to try on your own. Find the least common multiple of 50 and 90. And pause the video, and magically the answer will appear to go through together. So I'm going to pause. I'm now unpaused. Work through the answer. Here's the factor trees for 50 and 90. Start with the smallest number. There's 1 2 here and 1 2 here. So it's a tie again. But the question is, what's the biggest number of 2's in either of the factor trees? And the biggest number in either one is there's 1 2, so I'm going to use 1 2. The 3's, there are no 3's here. There are 2 3's here. So this is the biggest number of 3's in either of the trees. So I'm going to use both of those. And for the 5's, I have 2 5's here, 1 5 here. Which is bigger between 2 5's and 1 5? Yep, it's the 2 5's in this tree. So I'm going to use the 2 5's. And from there, just trust me that if you multiply all these out together, you should have gotten 450. If you didn't, look back through, see what you might have done. And then certainly, I'm going to pause this in a moment. I'm going to write down and go over with you the assignment for today. But please feel free. If you have any questions, you don't understand a problem, respond to the email that I sent you, or that I will send you here after this, because I'm trying to get you the answer keys for the previous lesson, Chapter 5, Lesson 3, but I've been having trouble with my phone transferring those pictures over to my computer. So, for the moment, I'm going to pause, and when I unpause again, you will see today's assignment. Okay, we're back. So here is your assignment from this teaching. Lesson 5-7. It's on pages 208 and 209. And you'll be doing problems 4 through 9 and 12 through 29. So again, feel free to watch and rewatch this video. Email any questions to me that you may have using my school email address. And you'll have that too when I send you an email with the answer keys for the homework from last week, which again, may take me a little bit of time with the technical glitch, but I will get it out to you today. So signing off for this one, staying warm here. Hope you stay cool there. Looking forward to meeting you again via this with the practice test on Wednesday. Bye for now.